What's up, y'all? How you all doing? A few days ago, I was experimenting as usual using high voltage power, and I noticed something weird. The paper somehow, it is difficult to say, it was kind of glowing. After I saw that, I was like, what is happening here? Like, why does the paper glow blue? Now, we all know the fact that when two terminals or two wires are brought together when they are at high voltage, the positive and the negative attractions between the two terminals will cause the air molecules to line up to create an easiest path for the future electrons to come. Now, when that happens, once the molecules are perfectly aligned, now electrons have a path, a new path. So electrons will jump one atom to the other. Jumping, jump, and boom. There are two types of electromagnetic radiation, and I'm pretty sure you're familiar with them. There are two types: ionic and non-ionic. Non-ionic radiations are radiation that just cannot just knock electron out of stuff, you know what I'm saying? They don't have that significant power. For example, radio waves. Radio waves are very faint, very weak. They are non-ionizing radiation and they pose no threat. They cannot just knock electron out. For example, microwave radiation. Microwave radiation at its own properties, wavelength properties, it cannot easily knock electron out. Sure, it may vaporize water, like in an atomic scale, but still they don't knock electrons out. Or visible light even. Visible light, they're not strong enough, but here are the stronger ones. Ionic radiation. This is the exact opposite. If you radiate this kind of radiations, the following radiation, you can easily knock electrons out of an object. For example, UV light. UV light. We use it in different material, for example, in some lasers or in some nail polish dryers or in a bug zapper. X-rays. We all know about X-rays. And guess what our high voltage is producing? A UV light. The harder the electrons knock, the higher power it's gonna produce in terms of radiation. If the speed of the electron is very small, it will create heat or light, just something that is not dangerous, which is a non-ionizing radiation. But I don't think we can produce a gamma ray. But it's in my bucket list. And then it hit me. Oh shit, I'm producing UV light. And everybody knows, like, it's kind of a stereotype. If you get hit by a UV, you get cancer, a skin cancer that you may not recover from. And who wants cancer? You see that logic? So I get worried because I've been doing high voltage for nearly a year and I've been absorbing UV light like I did what any normal guy would do. ChatGPT did. So yeah, I asked the question and later found out that the radiation that I was making was far too small to cause any kind of damage, cellular damage or DNA damage. So yeah, I ChatGPT'd it and it turns out that I'm making a radiation called UVC. Think I'm cooked. But no worries. Forget it. I'm not dying, okay? I'm not dying of cancer. Said, oh, thank God, you know? Ultraviolet radiation, especially UVC, it gets absorbed way quickly. Just a few centimeter gap from the air. You see why I say thank God? Because if there was no air, I'll be cooked. I would have cancer, skin cancer all over me. Science is pretty cool when you do it, especially if the effects that you are seeing from a scientific experiment is cool and good. But it's also dangerous, very dangerous. One miscalculation, when you do science, please be careful. And don't be dumb like me. I'm a lesson. And again, I'm not gonna die of cancer, okay?